Start the PowerPoint though, probably, yeah.
I will in just a moment.
Okay.
Hello, can everybody hear me? I guess this is Melissa Chimera. I think I'll try to get the audio working for everyone. Hello, this is Melissa. I think our audio is on. Can everybody hear who's on?
Looks like.
Okay, I think we're gonna go ahead and start. Good morning, everyone. This is Melissa Chimera with the Pacific Fire Exchange. I hope that you can all hear me. Thank you all for joining us for this morning's webinar on fire and erosion. This webinar is brought to you by the Pacific Fire Exchange. We are one of 15 nationwide networks in the Fire Exchange Network, and the goal of the Joint Fire Science Program is for research to support sound management decisions. The PFX, the Pacific Fire Exchange itself, is a wildfire communications project that shares knowledge, research, resources, and experience for better wildfire outcomes in Hawaii and the Pacific. Our founding partners, as you can see here, are Hawaii Wildfire Management Organization, the Institute of Pacific Islands Forestry, and University of Hawaii at Manoa's Cooperative Extension located in the College of Tropical Agriculture and Human Resources. The kinds of things we do include things like this webinar, field trips, workshops, fact sheets, research briefs, and our newsletter. So please sign up on our website. And one last note is that this webinar is being recorded. We also ask that you please complete the feedback survey at the end of the webinar. A separate window should open up in your browser at the end that will direct you to the survey. Your feedback is really important to us and we use it to improve what we do. So with that, let's jump into the webinar. And I'd like to first introduce all of our speakers. Jack Minassian, if you can just come on over here and look right there.
Hi, my name is Jack Minassian. I'm an assistant professor at Hawaii Community College. I'm also the Fire Science Program Coordinator. I have 35 years experience in the fire service, starting in 1965. I retired in 2004 as a Pacific Island Fire Management Officer at a Hawaii Volcanoes National Park. I was nationally qualified as an Incident Commander Type 3, and I'll leave it at that.
Thank you, Jack. Okay, Clay, take it away. Please introduce yourself.
Yeah, my name is Clay Trauernicht. I'm actually the principal investigator listed, the sort of lead of the Pacific Fire Exchange, and I'm based at University of Hawaii, where I'm the wildland fire specialist with Cooperative Extension.
Thank you, Clay. And Willie, last but not least.
Hi, everyone. My name is Willie Rice. I'm a forester with Forest Solutions. I've been here for 15 years with this company. My experience in forest management is from Colorado, New Zealand, and Hawaii. And I don't have a lot of direct firefighting experience, but the forest management side, and it is where my experience comes in to play for this one.
Thank you, Willie. So today's format, we're going to have Clay first up talking about the earth science component of fire and erosion. And then from there, I believe it's going to be Willie who will then give us a land management perspective on fire and erosion. And finally, Jack Minassian will answer any questions and give his perspective as a National Park Service fire director dealing with it on public lands. And then last but not least, we will want to hear from you all with your questions, and you're welcome to go ahead and type those out if you like. There should be a menu to do that on your webinar. So with that, take it away, Clay.
Okay, yeah, I'm gonna try to make this brief and just talk a little bit about the science behind fire and erosion impacts, but try to also cover kind of assessing soil burn severity and some of the strategies to mitigate fire impacts related to erosion, mostly sort of after a fire has happened. And so really what's driving soil loss on islands, fire is a really obvious short-term kind of input to soil loss and sedimentation or sediment delivery to the reef. So once you get all of that vegetation burned away and you expose the soil, it sort of drives the rate of erosion from a given place. But fire also contributes to erosion over the long term, and this idea of the grass fire cycle, in which repeated fires will shrink the forest cover in an area, and grasses, and especially in Pacific Islands, invasive grasses and sometimes native grasses will come in to replace forest cover. And grass cover, more generally speaking, is related to like increased surface flow of water, movement of water over the surface, which can also increase erosion relative to forest cover, decreases infiltration, so the amount of water that's sort of trickling down into the groundwater. So that's sort of over the long term. And then in other islands outside of Hawaii, so in Guam, for example, we also see in these grasslands repeated fires contributing to badland expansion. So these are the expansion of these bare areas, which is of course a really important sources of erosion. Next slide, please. Am I driving? So I think I put this slide in every talk I've ever given, and really it's just to place this in the context. We can think about fire kind of on the bottom part of that graph over seconds, days, and decades, right? So it's from a flame actually happening to a wildfire event, all the way to this idea of fire regimes, which are repeated fires over time. And of course, thinking about the size of these different events on the y-axis there, like going up and down. And really, when we're talking about erosion, primarily we're thinking along the lines of wildfire events, right? And so Jack's going to cover a little bit about some of the actions related to preventing erosion, actually responding to fires, you know, and in the aftermath of that. I'll be talking more about mitigating erosion after the fire event, and then Willie's going to be getting into some of the concerns with erosion that are related to fire prevention, doing fire break management, things like that. So next slide. I think usually, as what I like to say is, you know, fire science is really cool and interesting across many different aspects, physics, chemistry, ecology, but ultimately we're really concerned in studying it because it poses threat to resources that we value and has different kinds of effects on those resources. So that's really why we're interested in studying fire at all. Next slide. So there's a pretty important distinction to make between fire intensity and fire severity. And the basics here is the fire intensity is actually a measure of the fire itself, how hot it's burning, and really it's just the energy output. And that's going to relate to the fuel type that you're dealing with, right? So how much actually biomass is in there, how fast is the fire moving through that. And we usually do these proxy measurements for fire intensity. We use flame height and temperature. So temperature itself is actually not a direct measurement of fire intensity because fire intensity is the energy that it puts out. And so the effects of fire on vegetation and soil, that is what we refer to as fire severity. So how badly did the fire damage the vegetation and the soil in an area that burned? And that is not only a function of the energy output of the fire, but this idea of residence time, which is just how long did the fire stay or continue to burn in a given place. And so the longer time it burns for, and the more energy it's cranking out, typically the more severe the effects of that fire is going to be. And we distinguish that between vegetation burn severity, so the effects on vegetation, and soil burn severity, the effects on the soil. You can jump to the next slide. And so what's actually going on when a fire is moving over a given part of the landscape or through the vegetation is you're getting combustion, right? So things are actually burning and being consumed. So that's leading to plant mortality, the release of the carbon contained in the plants into the atmosphere through smoke. And you're also getting combustion of litter, the duff layer, and humus. So that's sort of those layers above the soil on the forest floor. And if any of you have sort of seen fires or the aftermath of some of these fires in some of the vegetation types we have in Hawaii, things like ironwood, those fires can actually burn for days and days in those litter and duff areas. So you can actually have a low intensity fire with a long residence time in those examples, where you could actually have pretty intense effects on soil and it can damage the soil. The other thing that's going on is the heating of the soil organic matter. And so soil is primarily a really good conductor, so you don't typically get a lot of heating down very deep in the soil. It really depends on how moist it is and how versus how dry. But what ends up happening is you can actually get heating, which will release nutrients and volatilize some of the soil nutrients in there, and you can actually start breaking down some of that organic matter that's in the soil, and this has different effects on soil properties. And one of the interesting things that it does is there's this water repellency effect that often happens, and sometimes you can actually see this in a really intensely burned area, that the soil almost looks like it has this sheen or glossy coat on it. And you go to the next slide. It's a really interesting effect. What ends up happening is you've got these sort of water repellent materials within the soil, and once it's heated up, those tend to sort of literally like melt and kind of seep down into the soil. And what ends up happening is once that water repellent layer is established, you get big increases in surface runoff. So the water will just rush off those areas of soil, which leads to higher flow or more water flow downhill from there, downslope, which will pick up more sediment and can increase erosion. Next slide.
Clay, we do have a question from Nani Barreto, and she is asking, what else drives soil loss in the Pacific besides fire? So just kind of big picture.
To give you context, so one of the big things is just anywhere you have exposed soil, right? So things like construction sites, farms, if you're not kind of keeping crops in constant rotation, trails and dirt roads are big sources of erosion. And it's actually one of the questions that we haven't sorted out, the scientific community, I suppose, is that what's the relative contribution, right? So how much does fire contribute relative to these other sources of sediment? And it's a challenge. We're still kind of figuring out how the best ways are to measure those sources. But we do know that once you get a burn in an exposed area, it definitely increases the potential for erosion, right? Which would be driven by rainfall events following that fire.
Okay, thank you.
Yeah.
Should we go to the next slide?
Yeah, the next slide is actually kind of contributing to that answer a little bit. So what ends up happening is you get increased erodibility, right? So all of a sudden you lose that vegetative cover and your litter cover. And so that just, the biggest effect of fire is the fact that all of that soil is being exposed directly to rainfall, right? So when those raindrops drop onto the soil, you get the movement of materials downslope with the water, right? And so the other thing that happens is once soils heat and that organic matter inside the soil can actually burn, it reduces soil aggregation. In other words, a lot of that organic material is really important to hold soil together, and so it loosens up the soil, and you could actually see that. I've got some examples there. And then all of this is really relating to that increased delivery of sediment with water flow over the surface of the burn area and also downstream as well. And then these changes also increase surface runoff. So in other words, the quantity of water moving over the surface versus the quantity that's infiltrating down into the soil. And so you have reduced evapotranspiration. In other words, there's less plants pulling water out of the soil and up. So you're going to have more water, or the water table will be higher under that burned area. It can reduce surface roughness. In other words, that kind of sheen and shiny area, and then all of a sudden you removed all this plant material. There's just nothing to slow down the water movement down slope. And then there's also that effect of repellency that I discussed earlier, that sort of hydrophobic or that sealing effect that burns can have, particularly high intense burns. So with that being said, I'm going to move on to some of the response. You can go to the next slide. And ultimately, it's kind of like anytime you have a fire and you're either trying to assess the assets maybe that were threatened, but it's the same thing for erosion potential. You really are trying to get a sense across this burn area of what was the relative severity of the fire, you know, which places burned hottest and had the biggest impact on the soil, and then kind of sussing out erosion potential, right? So how much vegetation was lost? Are you dealing with different slopes? So erosion is going to be much worse in steep slopes and even vary across soil types. And that allows you to prioritize management areas and then kind of consider what options you might want to try to mitigate it. And there's some resources here. So I throw up some stuff that we've been working on over the years. So Hawaii Wildfire Management Organization has this post-fire response guide that we can share. We also have a monitoring guide for vegetation and soil monitoring. And there's something that Jack Minassian and I were talking about yesterday is the federal agencies have this Bear Area Emergency Response Teams. And these guys are going in oftentimes when the fire is still burning to assess what are the impacts of this fire and then in the post-fire environment. And you know, the problem, generally speaking, in Hawaii is we don't have any here in place. And so when they come in from the mainland, it's much different conditions than they're used to seeing. So I don't know if Jack, if you had anything you wanted to add to that.
No, I think I can talk about that later.
Okay, great. So yeah, the first step in this whole process is just assessing fire severity. So you've got some pretty obvious indicators. They're pretty intuitive, I think. You know, for vegetation, of course, you can use crown scorch. So in other words, like how much of if you have trees, how much of that tree canopy was actually directly damaged by the fire and heat. Plant mortality, right? So like how much of that vegetative cover was consumed or killed during the fire, and then also litter and duff consumption. In other words, like how much of that ground layer in the understory is exposing the soil beneath. And then soil burn severity indicators really are about color, texture, and aggregation. There's another test you can do where people will actually do an infiltration test. And that's really, literally, it's taking a cup of water and pouring water over different areas of the soil and just timing how long it takes for that water to seep into the soil. Whereas lower infiltration rates indicate higher soil burn severity. And I think the next slide, I show some examples of high, moderate, and low. So you can see on the left-hand side, these are the high soil burn severity. You can see that like powdery texture in the top slide. It just is indicating that all of that organic material that was in that soil that might have been binding the particles together is gone, right? So this was in an area where you had eucalyptus and it just burned super, super hot. There's a kind of zoomed out picture below that. That discoloration in the soil, almost all of the litter layer and duff layer has been consumed. So all of that is just sort of bare exposed soil. Compared to the moderate soil burn severity, where you're getting some discoloration. I mean, if you look closely at that, you start to see some of this kind of crumbly texture, indicating that some of that soil aggregation effect has been lost. Also, a lot of this litter and duff layer in the understory has been consumed. And then low severity fires in that top. So you actually see an leafy seedling coming through, and you can see it burned through that, but there's still a nice litter layer left on the forest floor. In the photo below that, you can actually see a lot of plant material that was actually burned through a luhe. Up on Oahu, in Kipapa, there was a fire there in 2015, and that you can see it burnt most of the vegetation off the top, but actually the soil was left intact. You've got a lot of vegetative parts there, you know, the rhizomes from the luhe actually there to kind of protect that soil and hold it together. So we would consider that low severity. When it comes to prioritizing management areas, there are some computer models that are, I guess, pitched as being accessible. Again, our biggest limitation in Hawaii, like almost everything else, is that they haven't been quite fine-tuned for our conditions. And so we haven't done any sort of validation to say how well do they work. But there's obviously some really more intuitive metrics to prioritize. So steep areas, right, are going to experience the most erosion off of these areas. And then when you're looking at soil burn severity or fire severity itself, it's just prioritizing those areas that burn hottest. So when you look at a large fire, you're going to have areas that burn really hot, areas that didn't burn as hot, depending on what the conditions were and the fuel types were when the fire moved through. The other thing to consider is just, does the fire impact in that post-fire environment affect any of your assets at risk? And so when the bear teams come in to these areas, where they're really looking at is like, do we have increased risk of things like landslide, debris flows that are going to impact homes and other infrastructure downslope of the fire? So again, sort of stacking these things all up to try to use your best judgment to say where, if we're going to take mitigation actions, where should we be doing those to have the biggest effect?
Clay,
yeah.
Speaking of mitigation and assessment, we have a question asking who has the responsibility of doing these assessments, of assessing fire severity in Hawaii? And part B of that question is, how do the results inform guide next steps? Maybe that's a little bit later on.
Right. So good questions, both of them. The responsibility ultimately comes down to the landowner. You know, this is something we have kind of saved for later, but just to touch on it a little bit, there's really no resources in Hawaii outside of the federal agencies, so Fish and Wildlife and national parks, that actually have access to funds to do post-fire rehabilitation work, right? So that's the first limitation, is availability of funding to even do the assessments, and take any action afterwards. That being said, I've helped a lot of folks on doing just post-fire assessments, trying to figure out where was the most damage done. And as far as prioritizing actions afterwards, again, on one perspective, fire gives you this clean slate. If you want to do restoration and you're sort of prepared to do restoration, that's kind of the bigger question. It does a lot of the work for you as far as clearing out areas. I will say this, though, that the majority of fires we have in the state are in these grasslands, which are, either non-native grasses, maybe some rangelands, areas that had maybe been grazed prior or in the past. And so when those grasslands burn, even though you get a lot of soil exposure, the vegetation burn severity isn't that high. The grasslands come back quite quickly. So this is really one of the areas of prioritizing. This might be just looking at, when you have forest areas that are impacted that don't recover as well on their own. And of course, when native ecosystems get impacted, they typically are much more vulnerable to this weed invasions coming through. So yeah, I don't know if I answered your question or just sort of rambled there, but
no, it's a good one.
Follow-ups, just don't feel free to ask.
Okay.
And then the sort of other part is just thinking about erosion control. And before I kind of dive into this table, this research that's been done on this, there's a lot. It's all coming from the mainland once again, primarily in areas like Colorado, the Western U.S. So the degree to which they apply to us and have been tested here is pretty limited. We don't, have a lot of examples where we're doing this kind of action. But the two strategies short term are really direct seeding. And the evidence for that is pretty limited as far as erosion control. It may help rehabilitating the vegetation over the long term. So direct seeding obviously will help get plants established after the fire, but it has very little effect, if any, on actually preventing erosion. And there's a really detailed synthesis of that available that I can share. That I've put some references there too. But if anyone wants to see that, just reach out to me directly. And then there's been some more work done on these erosion treatments. So this guy, Peter Robichaud with the U.S. Forest Service, has done a lot, and he's compared these methods that are listed under treatment on this chart. So he's done straw mulch, wood mulch, hydro mulch, contour felling. So it's when you sort of lay down logs across the slope, and then straw wattles. So the same idea as contour felling, but just using these straw wattles. We've done there was a fire in the Waianaes where we did straw wattles that seemed to be effective at trapping sediment. But the best effects, so when you look at these conditions that they tested this under, you've got high intensity rainfall versus low intensity rainfall. And so, you know, low intensity rainfall in the Colorado Rockies is probably like, we wouldn't even think it's raining here. I mean, so it's hard to make some of these comparisons. And then they also compared the effect of these under like a large quantity of rainfall. So see like, you know, 4 inches of rainfall over the course of a couple of days. How well did these things work? The last column there, feasibility, is really some of my guesses. And we might want to talk about this if people have experience directly who are on this call, but based on just some brief discussions with people, but also some brief research into cost of materials, availability of materials. But the short story here, it's probably too late for a short story, but the short story is that mulching has the biggest effect in preventing erosion. And the reason for that is that you're actually covering all that exposed soil. And so when you get rainfall events, you don't get that soil movement that I was discussing before. So it really helps hold down the soil. Contour felling is less effective at that, especially under high intensity rainfalls. And a lot of the reasons for that is that it can flow around the logs. But that being said, it does trap sediment, right? You can actually collect sediment moving off of a burn site with contour felling. And similarly with straw wattles, right? So they're not protecting the direct impacts of rainfall on the soil. So you're going to get soil movement, but you can kind of trap the sediment that's flowing down the stream. So it's not to say that they're a waste of time. They still can be effective. And then as far as feasibility, we can get into the details here. We know one of the big problems with mulch and the hesitation people have around mulch has to do with the coconut rhinoceros beetle, right? So there's some hesitation with that, but it's simply the availability and moving some of these things at quantity. I know on Oahu, they've done in-site mulching. So the Army Natural Resource Program has actually delivered a chipper up into the forest and used chipped guava to try to do weed control. So this wasn't related to fire, but I was saying that the wherewithal there, if you have the motivation, people have been doing this with on-site materials. Hydromulch might be more difficult to get into some of those difficult to access places, but there's been some work and there's ongoing work with hydromulch, looking at some of the advantages, especially at places you can reach to the road, and getting the plants started post-fire. And as I said, we've seen some straw wattle. We've used that on a fire here in Waianaes years ago. And again, it trapped sediment, but didn't really have that protection quality that the mulch has. So at any rate, maybe you want to get that into discussion later about what is the feasibility of some of these actions. So contour felling, obviously you've got materials there. If it's in a forest, you can lay down trees and cut trees accordingly. Next slide, and then I think I get to pass it off. So just also thinking about this over the long term, a lot of work on this in Guam, mostly where they've looked at the effects of reforestation. And so they had this area that they planted a whole bunch of trees, and they actually did these erosion traps, these sediment traps, and compared that to a neighboring grassland area. And what you can see on that graph that's there is the depth of soil in the green areas, the tree planting areas, versus the reference plot, they call it, basically the grassland area. And you can see where they planted trees, they're just accumulating soil, right? So there's something to be said, all that to say, there's something to be said for reforestation efforts in mitigating erosion. So that kind of addressing that longer term effect. With that, I think actually we reverse the order. We're going to pass over to Willie.
Okay. And I will, there's a question that came in, but it has more to do with management. So I'll save that for the end. Willie?
Hey, actually, hold on one second. Little technical glitch here. I'm noticing you might not have opened the right PowerPoint because Willie's slides are not in here.
Oh, okay.
So
Pause.
Give us a second.
Yeah, 1 second.
No pressure. guess, I mean, if anyone has questions, I don't know if I can see them that come up in the.
Well, while I'm opening this up, I will pass on Melanie Lander's question from the Hawaii Office of Planning, Coastal Zone Management. And again, it ties into management responsibilities. You've partially answered this question already, but she's wondering about responsibility, specifically about fallow fields in former sugarcane pineapple plantation areas. If there's any mandate to reduce fire and erosion on those specific areas.
Yeah, the only sort of legislation that I'm aware of is that counties have brush abatement laws. And typically those, as far as I know, and this just comes from my discussions with firefighters who kind of have to do some of these inspections, it typically relates to abating brush within the border, sort of along the border, the boundaries between their properties and other folks' properties. So beyond that, I don't think that there's anything really dictating what people are supposed to do on fallow lands, especially not after a fire event, right? So if those areas do burn, I don't think there's any regulation stating that someone has to try to mitigate those the potential impacts or potential effects of erosion. So.
Gotcha. Okay, I believe we have the correct presentation now, and here's Willie's section. 1 second here. Okay.
I think actually we might have slide. So
This is the one that you sent me, Clay. So
Clay, can you share your screen on your side?
yeah,
well,
why
I
don't
think the slides come up. If you go to next, oh no, it doesn't have. That's the one I sent. Here, switch presenters to me.
Okay.
Sorry about that, everybody. Technical glitch. You got it?
1 second. Clay. Okay, Clay, should be on yours.
All right. Okay, everybody see that?
Yep.
So your slides are here, Willie.
Yeah, I'm waiting for them to come up on my screen here.
Is it not showing?
No, not on mine.
Hang on a second. It's maybe the presenter. You don't see those?
Oh, no, I do, yep.
Okay. You got them?
Say it must be real slow. There we go. Okay, yeah, you can switch to the next slide then. Okay, here we go. Yep, now I see break planning and land planning now. Perfect. So the intention of your fire breaks really is a result typically of the management in an adjacent area. So you got to be real clear on the purpose and what you're doing with management, and important to spend time defining your unit too. Whether it's what the boundaries of your unit are. Your fire breaks, fuel breaks, they could be any one of the ones listed or any reason. And it really relates to that adjacent management area. And what we do at Forest Solutions is we do this thing called land reconciliation, where every acre is a polygon in some way. So whether it's a road, it's not necessarily a line on the landscape, it's actually a polygon that has a width to it and a distance. It's easy to think of that in some sort of forest management unit, but when you apply it to a line or point like a water source, you've got to think of it a bit differently. But a water tank will actually have an area to it that you want to manage around the water tank, similarly to a road. So part of that management within any one of your units, whether it's a fire management unit or some sort of forest unit, you're going to want to ask yourself a question, is fire okay here? And of course, in Hawaii, generally speaking, it's really not okay. but is it so far away that it's almost that it is inaccessible for fire response? You've got to kind of say, well, actually, I need to let this place burn because there's no way I can really consider any sort of fire response other than maybe a helicopter getting there to do something. So if it does then burn, how do I minimize the damage or my response time to that area? Maybe it's a day or a day and a half to really get whatever firefighting equipment there. What can I then realistically do? So prior planning obviously is very important. Go ahead to the next slide, and I'll show you an example in this picture. On the satellite image there, you'll see quite clearly the burn area, and then the colorful one on the other side is from clay, and the red there shows grass regrowth, the blue is soil, and the green is a forested area. So this is a fire in 2010. Both these images are around 7 years post. And what occurred during the fire is, of course, mass mayhem to some extent. Several bulldozers out there cutting fire breaks, and sometimes with a spotter, sometimes without. And they did a good job, but this is also for hoi, so it's much more slow than building fire breaks in dirt and whatnot. And my point really is that it was really difficult and ended up being really expensive at the time. And if we had a better idea of where to put fire breaks on the landscape beforehand, we could have done all this work a lot cheaper. Because what resulted is, you see the fire boundary, we built fire breaks along roads there. So if we had done good planning and put in fire breaks prior, we could almost sit back on our haunches and just watch this fire burn up to these boundary units. It's not ideal, but it's much more cost effective and a lot less worrisome when it comes time. And then you're just you're maintaining that fire break if the fire approaches. And so really that's the concept of trying to question you folks is that you really take a serious look at each unit, whether you're happy with it burning or not, and to what extent. A good example, again, on this fire, it ended up being about 1,000 acres, and not happy with 1,000 acres burning, so maybe we should have put in another fire, or now we should put in another fire break that kind of cuts it across. So maybe there's 500 acres that we could potentially lose. And you see the surrounding area on the satellite image, that's what we lost. And that's beautiful. We have full forest there. And like I said, 7 years post, nothing's come of that. But this grassland, very, very few trees. And that leads in, again, to what Clay was saying about restoration. So not only prior planning, but the restoration after the fact. If you do have some sort of burn acceptance or fire acceptance in a unit, and you sort of manage unit, if it does burn, okay, maybe you did a good job with your fire breaks, fuel breaks, and planning. And what happens then after? It's not inevitable that every acre is going to burn, but just in case, have that plan so that you know, hey, this area will burn instead of remaining grass for the next 20 years. I've now collected seed for the prior 5 years or so, and I can scatter seed. It takes a lot of foresight to do something like that. It's a lot easier said than done. Go ahead, next slide. So over the course of the years, my experience in forest management includes radiata pine in New Zealand, eucalyptus forest here in Hawaii, and native forest as well. And these are some basic rules that we kind of use, whether you're building a fire break or a fuel break on lava or rock, any sort of a rock road that's not going to erode a lot. That's kind of an important bit there. Versus on dirt, fine to use a bulldozer. You've got to plan that well. But when you're on some sort of rocky substrate, you go ahead and spray. It's much more difficult to mow because you're going to break the mower every other time you go out there, probably. But on dirt, if you can get away with mowing with your fuel breaks, then you're much better off than spraying because you're going to create a lot less erosion. I've got some example pictures to show, but yeah, why don't we move on to those pictures? So you guys can look at that slide enough. Seems to be a lag here. Okay, here you go. So this is an example of a fire break in lava country up above Kona. You see the aerial photograph on the right there. It's quite an extensive fire break, and it's meant to be that, a fire break, not a fuel break. And you can see on the left there a recent spray of the sides. You constantly have some sort of grass encroaching, and if it's not grass, you've got some sort of broadleaf coming up on that fire break. But here you can see, you know, you're not going to get a lot of soil movement. There is no soil, but you're not going to get a lot of rock movement. It's a pretty good solid road. So I can really keep and maintain that. And it's important too that when you're in a natural area versus when you're eucalyptus plantation or something like that, you've got to treat a fire break as a fire break. And I might spray some you know, something that is valuable, but I'm happy killing one plant to save the many. You recall that one in our picture, we lost 1,000 acres of beautiful forest, whereas if we killed a few to make sure I had the right width fire break and save that whole entire area because my fire break didn't work, everyone would have been much happier. Go to the next slide, please. It's quite a lag.
Yeah, sorry about that.
All right, there you go. Okay. So this is another spot on the Big Island here, and this one is unique because this soil it's like baby powder basically. It runs away the second any water falls, and you can't tell in the photo here, but it's probably about a 30% slope. So what we are protecting is within the fence. It's a dryland restoration enclosure, and we built a fire break around it, and we wanted it to be a fire break, not a fuel break. It's pretty rough country, so we couldn't mow, but we have terrible erosion, so we're trying to come up with a good way to, you know, keep this really fine dirt from running off. So we took the bulldozer and actually started excavator in, and it's hard to see in the photo, but there's a water bar or a swale there, and right in the middle of the photo you can see a bit of a little gully forming there. And so you see it doing its job. It's running off to the side there to deposit into the vegetation next door. The other thing we did is we sprayed calcium chloride on here as well too. It ended up being a bit of an experiment at first, but ended up working really well. If you're not familiar with this, they use it on the mainland a lot, and it's just kind of a dust retention type of a chemical, and it creates a bit of a hard layer on top, a little bit of a crust, and it was really successful here because of the fine soils. And it's essentially, calcium chloride is essentially damperate, you know, or a desiccant or something like that. So you spread it out, whatever the most efficient way is. We use the tractor, just a regular fertilizer spreader on the back of the tractor. Spread it out, and it kind of grabs the moisture out of the air and binds in that top layer. This photo is about 2 years old, and you could walk across during a kick up some dust, but when you get rain, there's just enough of a crust to retain that soil, and it's far exceeded the lifespan that we expected. Go ahead, next one.
Willie, we have a couple of questions asking about the difference between fire and fuel breaks. They've been used interchangeably, sometimes in the literature, sometimes not. So can either one of you address that for our listeners?
Sure. So fire break is a good example is the one I cut in the lava field there, where you have absolutely no vegetation on it, so nothing is going to carry a fire. Whereas a fuel break is like in this picture that you see, it's a modified vegetation structure. So in this one, that grassy area was mowed, and it's meant to really slow down a fire, maybe stop it if you're lucky. But you still have vegetation, so you're modifying, managing the fuels that are on that break, and not creating a complete break in potential fire being carried.
And the part B of that question related to fire breaks is how do you calculate the width? Are you looking at like wind pattern or extreme wind potential? Is it just like whatever you can do? What is what's the general idea?
The next webinar.
Oh, okay.
Right.
You can answer, but yeah, we had to do one on that too. So we'll go ahead, Willie.
Yeah, I would say 2 to 3 times the height of what you got, but really on the ground, functionally, it's what you can afford. Wider is always better because these winds are crazy in various places, or not. But it's what you can afford in the width and how valuable that asset is. For example, if I've got, my house in the middle of mountain grassland, I'm going to make it pretty wide. But in the eucalyptus forest, a road width of 20 feet is going to give me defensible space because I know the access is good, and I can get firefighting equipment in there to fight the fire going under, running away underneath these eucalyptus. But it is what I would say, realistically, is as wide as you can afford, without obviously being ridiculous.
Gotcha. Because you have to maintain that too. There's that maintenance cost that's built in. Gotcha.
Correct. Yeah, correct. I've got a slide on that coming up, folks.
Great.
So this one briefly is just to show a mowed area. Mowing is really, really, really cheap as far as creating a good, efficient fuel break. And just briefly, I just want to say, hey, if you can mow, if you can design your fuel break with a bulldozer prior so that you can mow afterwards, think about that. Mowing is great. Go ahead, next slide. I think the next one is on grazing, so very similar to mowing. And there's actually a you can do it. Come on. Yeah, the rest of you, are you seeing it, Clay?
Yeah, we can see it.
I see it on mine.
Okay. All right, here you go. So you see the fence line there on the right side of the photograph. So this is just an example of grazing as a fuel management process. We were grazing underneath the eucalyptus trees to keep the fuel load down. We still had a fire there, but as you can see, just adjacent to the eucalyptus trees where the cows had probably more feed, they like to hang out there for whatever reason a bit more. It did a good job of keeping the fire from spreading to the right side of the fence line, which is actually pasture. So it looks obviously a little bit high. But grazing fuel break, is a really good use. And once again, not necessarily always cheaper than mowing, because, for example, in eucalyptus, if I make some sort of corridor, and I've got 2 sides of fencing, and then my eucalyptus trees or whatever other trees might be adjacent are falling down on this fence quite frequently as well. So there's a lot of maintenance involved. So grazing can be great in the right area, as I think if people are familiar with Waikiki, really open area, they put a corridor that they put cows and sheep in and whatnot to graze it down, and that's wonderful, and you get meat. Go ahead, next slide. I think is the maintenance slide. So the maintenance bit is, you'll see on the slide, I just have some, kind of pointers, I guess, more than anything. And it's to work up a cost of what it's going to take you to, one, build this fire or fuel break, and 2, maintain it. It's inevitable that your boss is going to want things cheaper. So while you're doing it, recording the costs of whatever operation you decide to do is really important, so you can plan, because it always, for us, it comes into, we work backwards. We have a 5-year plan, we've got a 1-year plan, and then we've got an operational monthly plan. So it builds really up from the monthly plan into 5-year plan. But when you've got a really, really good idea of these costs, it's much easier to defend, and it's much easier to understand the implications on management. So, for example, say you have, $100,000 a year to do reforestation. What part of that is realistically going to give me good fire control in my new exposure? Is it 10,000 of that budget, or is it 50,000 of budget? And then maybe I don't want to do the enclosure anymore because I got to spend half my budget on fire control. So those are just, I think maintenance is often overlooked, and even our company has a hard time following with maintenance. You get busy, and you always say, I can let that fire break grow a little bit more grass on it, and next thing you know, you have a fire. So you really need a good plan, good cost budget, and a good schedule to get things done. And I think my last one is just touching on living and fuel breaks too, is my last slide there. And so I've done a bit of management on living fuel breaks, or green fuel breaks, or whatever you want to call them. It involves planting trees as something green in a dry area. This ups your ante for maintenance again, because you're now introducing a lot of trees, plants, whatever they are, shrubs, that might require irrigation, which could burn, that are typically growing in a really shrubby fashion, like an apple tree. So you need to prune things to get things up out of those fuels on the bottom. And you may not even want fuels underneath to begin with, so you have to go and keep these fuels out. So I don't want to discourage anyone from trying this, but you have to be very realistic on the cost, and the maintenance is I think higher on these green fuel breaks than just a straight up. And that's it. Thanks, everybody.
We actually have one more question for you, Willie, coming from Melissa Coons, our former PFX coordinator. She's asking, in what other cases would you recommend using calcium powder for erosion prevention? Willie?
Not on any sort of lava rock, gravel, large size gravel road. I'm thinking when they put out roads, right, there's half-inch minus, 1-inch minus, and things like that. Once you get to the half-inch size, you're probably going to get dust build up, and usually that's what we've done if it's used for on the mainland, is to control dust. But I think any soils in Hawaii where you want a fire break is worth a definite try based on our experience so far. Okay. Anything on lava rock, if.
Okay. Hey, Clay.
Can I pass it back to you, and then for Jack's last slide, and then
I'd rather, how about we just use what you've got, because you probably have the more recent.
Probably, but I don't even see. So this was for the audience, so now hang on a second. You guys hang in there. Here we go. All right.
Well, again, after 35 years in the fire service, I can say it's very complex. And so I'll just talk briefly, and that is, first there's the fire, and there are fire suppression efforts. And sometimes the fire suppression efforts are doing more damage than the fire itself. So again, traditionally, if you were digging fire line on a steep slope, rehab was just putting in water bars to prevent erosion. In the early 1990s, Yosemite National Park tried a different approach, and that is on a 60% slope, rather than put water bars, what they did was after the fire, they came back in and they dragged the material back in over on the fire line, branches, leaves, and so forth. A year later, you could barely tell that a fire line had been built. The rehab had been very good. They had also put in a dozer line through a meadow, which they didn't want to do, but they had to. Afterwards, they came in with a backhoe and they brought that material back in. And a year later, that meadow recovered very well. So what we try to do is what we call minimum impact suppression tactics, so that our suppression tactics don't do more damage. Hawaii volcanoes, we developed, rather than putting in fire line or digging fire line, we would black line, burn out areas. And again, by burning out, we're removing the fuel from the combustion triangle, and that puts the fire out. And by burning, we're not disturbing the soil, leaving the root system in, and that prevents erosion. With that being said, when I look at fire itself, what I found is fires, 90% of most fires are either low or moderate intensity. It's the high intensity fires that present the problem. And of course, the slope. The steeper the slope, the greater the erosion control. And of course, the high intensity, as Clay talked about, alters the soil and increases erosion. Also, earlier, somebody said, how wide should you make a fuel break or a fire line? Depends on the fire behavior. Sometimes a 2-foot wide line is all you need and will stop a fire. And other times I've seen fires jump Interstate I-5 in the mainland. I've seen fires burn homes right on the beach at Malibu. And the only thing that stopped it was the Pacific Ocean. So it just depends on the wind speed and the fuels and so forth. And sometimes the fire lines work, sometimes they don't.
Yeah. Speaking of prescribed burns, one of our earlier questions, clearly Hawaii Volcanoes is using or has used prescribed burns as a management technique. The question is, just how is it something that is done in Hawaii, considering the Hawaiian landscape? And, the second part of that is attempting to reforest those prescribed burn lands with native species. Is that an appropriate management technique here?
Yeah, what we found, basically what we found is in Hawaii, there are no native Hawaiian plants or animals that are dependent on fire for reproduction or success. What we have found is that there are several native Hawaiian plants that respond well to fire. Native pili grass, koa, mamani, ali'i. And so what we've done in some areas after a fire is we've seeded with pili grass, and then we reburn the area. And of course, the pili responds well to the fire, and then pili begins to take over. We did a study, 7-year study over at Pu'ukola Heiau between buffalo grass and pili grass. And we found that you can use fire as a management tool to reestablish the native pili.
Provided that it's not alien dominated, or can you convert?
Even though it was surrounded on 3 sides by buffalo grass, we were able to establish the native pili.
Okay, great.
So fire can be used as a tool also.
Awesome. Okay. Thank you, Jeff.
Okay. Oh, one other thing, I guess, talk about funding. And that is one thing. The federal agencies have some sort of funding, but typically the funding goes for the suppression of the fire. Once the fire is out, then people forget about it. And that's probably where we need more.
Okay, Jack, we have Dawn Bruns, and I'll just read what she's written. Federal agencies can do burnouts because they are protected by the Federal Tort Claims Act. I believe Florida has similar protections from civil liability for their state firefighters. Do you know if it would be appropriate possible to get a Hawaii tort claims legislation so DLNR our fighter fires can do burnouts without the liability litigation risk?
Okay, I have no idea about these tort claims. We're not protected. Federal agencies are not protected under federal tort claims. There was a prescribed fire in New Mexico that got away, and several homes were burnt, and of course the federal government was responsible. So there is no protection. Of course, when you do a prescribed burn, there's always that possibility of an escape fire, and that's why when you do a burn, you need to have a good burn plan ahead of time with a good prescription and a contingency in case the fire does escape. So litigation is not a factor.
Okay. And Melanie Lander from Coastal Zone Management again wants to know, are there any policy recommendations to prevent erosion, for example, mandatory management post-fire reforestation? I think the answer is that until we have funding for these programs, right, it would be an unfunded mandate. Is that fair to say to you folks, to you guys presenting?
Yeah, it's hard to say because, again, some areas don't need any rehab. Again, it would depend on the intensity of the fire, the topography. If there were areas, steep slopes that we saw, we would try to rehab those areas as much as possible. But again, limited funding, limited personnel. Where I've been on fires where we did rehab for just a few days and then we had to move on to other fires. We just didn't have the time or the funds to do it.
Okay. Willie, you want to add anything to that?
No, I think that's a good question. The funding for restoration is a big question and a very hard one to solve. I think from our work, when you plan that far ahead, it's kind of like, well, I never know if it's going to happen, so why am I going to commit any funds to it at a private?
Great. Okay, anything else? Any other questions? Okay, I'm not seeing any other questions from anyone. Well, it's 11 o'clock. You guys have been great. Oh, and there is a question from Jill. Will PDFs be available? This presentation is being recorded, so it will be available on the webinar platform. And PFX does have, and Hawaii Wildfire Management, 2 different websites. There are a number of products that are available. Fact sheets. Pacific Fire Exchange just put out a 2018 Hawaii Wildfire Summary that summarizes, stats and information about Hawaii specific. I don't believe we have anything specific, I think, Clay, on fire and erosion. Is that right?
Not yet, but we can post a PDF of this PowerPoint so people can check out the resources that are in there.
Great. Okay, and with that, I think we're going to end. Thank you all very much. Thank you, Jack. Thanks, Willie. Thanks, Clay. Thanks for all of you for tuning in. We appreciate your feedback. And again, please look for that survey at the end of this broadcast. Thanks again, everyone.